All right, guys, we are back. We have our next unit here is all about acids and bases. So we've got a number of vocabulary here, but a lot of them we actually will kind of know already. Acids and bases, we'll learn what our acids and bases are, and we'll just give them either the Arrhenius definition or the Bronsted-Lowry definition. We've talked about electrolytes before, hydronium and hydroxide ions. We'll talk about that. And then we'll really just mostly kind of talk about our pH scale, titration, neutralization, and what's happening with our acids and bases. Okay, so our objectives are, of course, down here. We'll compare and contrast our properties. We'll have our two different definitions of acids and bases, giving examples of neutralization reactions, doing a titration. But we're really going to start here down with this one. Understand how pH works, okay? So today, that's kind of our goal for today, is to understand how pH works. So overall, right, the pH scale is all about the power of hydrogen, right? That's actually where the pH comes from. And it's a direct measurement of hydrogen concentration. Whoops, didn't give myself quite enough room there. Hydrogen concentration in a solution, right? It's designed to measure either H plus or H3O plus, okay? So this would be the hydrogen ion. This is the hydronium ion, okay? This is hydronium here. Right, this is H3O plus. When hydrogen H plus is in water, it oftentimes will attach to that water and become H3O plus, okay? So the concentration of hydronium or hydroxide ions in a solution will determine whether a solution is acidic or basic, okay? So it generally ranges from 0 to 14, but we'll see some exceptions, okay? So anything that is acidic, our H plus concentration, right, if we remember here, our square brackets indicate concentration, okay? So our H plus concentration is greater than the OH minus concentration, okay? So in acidic solution, right, we've got lots of H plus, very little OH minus, okay? In a basic solution, we have the opposite, right? Our H plus concentration is much smaller than our OH minus concentration, okay? So this is acidic over here, and this is basic over here. What if our H plus concentration is equal to our OH minus concentration? That's when we are neutral, okay? So in a neutral solution, our H plus concentration is equal to OH minus, okay? All right, so we've got lots of different things that are acidic and basic. We'll talk about a lot of these examples in real life, but what we want to actually start with today is just getting our pH scale and understanding how to do the calculations between our hydrogen concentration, our OH minus concentration, pH, and pOH, okay? So pH scale is logarithmic, okay? So it's based on the exponents of the number 10. So if we have not used the log button before, we're going to learn how to use it. But if we go on to our calculator here, right, we want to put in log of 10, okay? So we see right up here is our log button, and then 10 would be our concentration, right? That'd be a really high concentration, but the pH there, or the log of 10 is equal to 1, okay? Log of 100. I go up here, log 100, plug it in, that's 2, okay? Log of 1, right? Well, log of 1 is going to be 0, okay? So if we know the rules of logs, right, that would always is going to be 0. And then log of 0.01, that's going to be -2, okay? So this is just doing math right here, right? If we have not used logs before, right, there's our log button. We just kind of need to know how to use it, okay? But now we're going to start applying it to our pH scale, okay? So here's our pH square. This is going to become really, really useful, right? Maybe you want to put stars all over it, right? I don't know. Do something, because this right here is going to become really, really useful for us throughout this unit, okay? So anytime we have the H plus concentration, and again, I'm going to put square brackets on here because that indicates my concentration, I can actually go from H plus concentration to pH to POH to OH minus concentration, right? I can go anywhere I want on this square, okay? So the first thing that I want to be able to do is go from H plus concentration to pH. So if I look here, right, here's my arrow, it says pH is equal to negative log of the H plus concentration. So if I come down to my example down here, I see, well, my pH, I want to calculate the pH of 1 molar HClO4. Well, HClO4, that would be hydrogen perchlorate. So we're going to get 1 H plus there, okay? We're going to get an H plus. We've got 1 molar H plus. So my H plus concentration is going to be 1. So then, right, I'm going to say, okay, negative log of the H plus concentration, negative log of 1, right? I go onto my calculator. Negative log of 1 is equal to 0. Okay, there we go. Okay, let's go to the next one, right? Now I want to calculate the pH of 0.5 molar H2SO4. Well, H2SO4, ooh, here I could actually get 2 hydrogens, but turns out that I get just 1 H plus from this. So my concentration is going to be 0.5 molar, right? So that's my H plus concentration. Negative log of my H plus concentration, that's going to give me my pH. So I go over to my calculator. Negative log of 0.5, well, 0.3. So my pH here would be 0.3. Okay? Let's do the next one. I want to calculate the pH of 0.1 molar HBr. HBr is going to split up and give me 1 H plus there. So if I get 1 H plus, well, that means my concentration of H plus is 0.01. So pH, negative log of 0.01, that's going to be a pH of 2. Okay, let's do one more here. pH of 12 molar HCl. Ooh, that's real concentrated, right? HCl, that's going to split up and give me 12 molar H plus. So negative log of 12, whoops, I get a negative 1.1. I thought we can't have negative numbers, right? The pH scale goes from 0 to 14. Well, we actually can. It's just very weird, okay? Like I said, this is really, really concentrated HCl, okay? So it gets a little bit weird because of that. So, like I said, we want to be able to go from H plus concentration to pH. We've got this equation here. But we can also, right, go from the OH minus concentration to the POH, okay? It's the same exact equation. It's the power of the OH minus concentration, okay? If we have our pH and want to go to the H plus concentration, well, then we can use this equation here, right? H plus concentration is equal to 10 to the negative pH value, okay? Same idea over here. OH minus concentration is equal to 10 to the negative POH, okay? So we should be able to go, right, up and down on these arrows, right? Now we want to be able to go left and right. If we have H plus, yeah, we can go over to OH minus, right? Using these equations here, right? If we're going from H plus to OH minus, we're going to use OH minus is equal to 1 times 10 to the minus 14th divided by our H plus concentration, or we can go the other way. But we can also, right, go across down here. Our pH is 14 minus the pOH, and our pOH is 14 minus the pH. Okay, so we want to be able to go left and right there. So if we go look over here on our next page, right, we should be able to go and figure these out. Again, right, we look at this question and we say, okay, 1 molar NaOH is going to be, well, I'm going to get lots of OH minuses there. Well, 1 molar OH minus, that's going to be my OH minus concentration. To get my pH, right, I can go to my pOH, and then I can do 14 minus the pOH to get to my pH, okay? So if I do that, well, negative log of 1, that'd be 0, 14 minus 0. Let me make sure that I do this right. Negative log of 1, right, would be 0. So 14 minus 0, that's 14. Okay, right? So there we go. Looking at that next one, right, it's a little bit harder because we've got 2 OH minuses there. Okay, so use this square, and that's going to help us. Okay, all right, we're going to pause there.